In this video, I want to do a number of practice problems from our moles practice problem sheet to give you more example problems to work from. This is a request I had from a number of students, so I thought we'd try it with this worksheet and see how this goes. For this, we're going to be working with that worksheet. We're going to start with problem number 2. In problem 2, you're given 7.39 moles of beryllium sulfide, BES. In A, we're looking for how many molecules do we have. We're going to use the factor label method. Remember, with the factor label method, two things. What we want to find goes on top. What we want to cancel goes on the bottom. So we're looking for molecules of BES, and we are trying to cancel moles of BES. We know that there is 6.02 times 10 to the 23rd molecules of BES for every 1 mole. There's 6.02 times 10 to the 23rd is Avogadro's number for the mole. We multiply this out, we get 4.45 times 10 to the 24th molecules BES. So that is our answer to A. For B, we're looking for how many atoms of beryllium. So we're going to start the same way, 7.39 moles of beryllium sulfide. Convert that to molecules. Since this is a compound, it has molecules. 6.02 times 10 to the 23rd molecules BES for 1 mole beryllium sulfide. Then we're going to atoms of beryllium. So for each molecule, that's what we want to cancel, we want to know how many atoms of beryllium do we have. If you look at the compound BES, it contains 1 atom for every 1 molecule. So our answer will end up being the same thing. 4.45 times 10 to the 24th atoms of beryllium. For C, we are going to go to atoms of sulfur. So once again, we start the same way. 6.02 times 10 to the 23rd molecules beryllium sulfide per 1 mole beryllium sulfide. In this case, we want to find atoms of sulfur per our molecule. And in this case, there would be 1 atom of sulfur for every 1 molecule. So once again, we would get 4.45 times 10 to the 24th atoms of sulfur. Number 3 is a very similar question to this, but in number 3 you're using a compound that is not just 1 atom of each element, that has different numbers. So these numbers up top here will end up changing in our next example, number 4, because we have a different number of atoms. So that's just dependent on the compound. In this compound, we had 1 beryllium, 1 sulfur for every molecule. If you had a different compound, these numbers would be different. The next problem we want to go to is problem 4. Because in problem 3 was an example the same as number 2, I leave that one for you to do on your own. For problem 4, we start with 6.50 times 10 to the 23rd molecules of sodium oxide. And we want to go to moles. Remember, the unit we want to cancel always goes on the bottom. The unit we want to find goes on the top. In this case, we want moles. 1 mole is Avogadro's number, 6.02 times 10 to the 23rd molecules. So we do 6.50 times 10 to the 23rd divided by 6.02 times 10 to the 23rd, and we get 1.08 moles of sodium oxide. For B, we're starting with 5.00 times 10 to the 24th molecules of CH4. Once again, we want to cancel molecules of CH4. We want to find moles. For every 1 mole, there are 6.02 times 10 to the 23rd molecules. So in this case, we would get 8.31 moles of CH4. Okay, for the next problem, I'm going to jump to 5a. So for C and D, you can try on your own. 5a, we have 5.0 moles of copper. We want to get rid of moles of copper and go to grams of copper. So 1 mole of copper is 63.55 grams. We find that from the periodic table. We multiply 5 by 63.55, divide by 1. Our answer comes out so that we have 317.75 grams. We round that to 2 significant figures, so 320 grams of copper. 5b, we have 8.00 moles of aluminum. We want to get rid of moles, go to grams aluminum. 1 mole, we find the molar mass of aluminum on the periodic table, 26.98 grams. And this multiplies out 3 significant figures to 216 grams of aluminum. So that is an example of 2 of the problems like number 5. Now if we jump to number 6, I'm going to do 6a next. In 6a, we have 8.00 grams of calcium. So this is going to be the reverse of what we were doing in 5. We're trying to get rid of grams of calcium and go to moles of calcium. 1 mole, we look at the periodic table, is 40.08 grams. So we multiply 8 by 1 divided by 40.08, and we get a final answer of 0.200 moles of calcium. For 6b, we have 560 with a decimal place at the end. That decimal place is there to tell us we have 3 significant figures of bromine. Once again, I want to cancel grams and go to moles of bromine. So this is grams of bromine. 1 mole, the molar mass of bromine, 79.90 grams. So we take 560, divide by 79.90. We get 7.0087, which rounded to 3 significant figures is 7.01 moles of bromine. So those are our answers to 6, A and B. Next, we're going to move to 7. I'm going to do 7, A and B to give an example of these type of problems. Now we have a compound. 5.00 moles of zinc oxide. Zinc oxide is ZNO. So I'm going to need to get rid of moles and go to grams. 1 mole, I need the molar mass of zinc oxide. So here I need to add up the mass of 1 zinc and 1 oxygen. Zinc is 65.38.
Can I have Devin Smith and Alex Young to the front desk, please?
Oxygen is 16.00. Our total mass is therefore 81.38 grams. So that goes here. Multiply 5 by 81.38. Round it. It comes out to 406.9, which rounds 2 significant figures to 407 grams of zinc oxide. For 7B, I have 6.00 moles of sulfuric acid, which is H2SO4. Trying to get rid of moles and go to grams of H2SO4. So once again, I'll have 1 mole. I need to find the grams of H2SO4. So I have 2H, 1 S, and 4 O's. H, 1.01 times 2 comes out to 2.02. Sulfur is 32.06. And oxygen 16.00 times 4, which comes out to 48 grams. So I'm going to add 48 plus 32 plus 2.02, which gives me 98.08 grams. So 98.08 goes up here. So 6 times 98.08 comes out to 588.48. Round it to 3 significant figures. I get 588 grams of H2SO4. Now if we look at 8, I'll start with 8A. 8, we're now going from molecules to mass. So for 8A, I've got 5.04 times 10 to the 23rd molecules. This compound is NABR. First, I need to convert molecules to moles. 1 mole is 6.02 times 10 to the 23rd molecules per mole. And then my second conversion factor is that there are, for NaBr, I need the molar mass, so I have Na and Br. Na is 22.99. Br is 79.90. I add those together to get the molar mass, which comes out to 102.89. So they're 102.89 grams in 1 mole. So I take 5.04 times 10 to the 23rd. I divide by 6.02 times 10 to the 23rd. I multiply by 102.89. Round to 3 significant figures. I get 86.1 grams NaBr. If I look at 8b, in 8b, I have 1.13 times 10 to the 24th molecules of CH4. I want to find moles first. Get rid of molecules. There are 6.02 times 10 to the 23rd molecules in 1 mole. And then my second conversion factor, I need to go to mass, so I want to get rid of moles, and moles now goes on the bottom. I want grams of CH4, so I need to do my little chart to figure out the molar mass. Carbon is 12.01, hydrogen is 1.01, and there are 4 of them. So when I add that, 4.04 plus 12.01, I get 16.05. So this is a separate. So 16.05 grams of CH4. So I take the 1.13 times 10 to the 24th, divide by 6.02 times 10 to the 23rd, multiply by 16.05, round to 3 significant figures. I get 30.1 grams CH4. Number 9, I am now going from moles or grams to molecules, not moles to molecules. So I have 5.00 grams S8. First I want to convert to moles. 1 mole S8. And sulfur 32.06 times 8 comes out to 256.48 grams. And then I want to go from moles to molecules, so 1 mole go on the bottom. 6.02 times 10 to the 23rd molecules will go on the top. So I take 5.00, divide by 256.48, and then multiply that answer by 6.02 times 10 to the 23rd, giving me 1.17 times 10 to the 22nd molecules of S8. So that's 9A here. For 9b, I've got 47.3 grams of O2. I first want to convert that to moles, so 1 mole O2. Oxygen has a mass of 16. There are 2 of them. So I have 32.00 grams O2. And then from 1 mole O2, I want to go to molecules. 6.02 times 10 to the 23rd molecules O2. So I divide 47.3 by 32, multiply by 6.02 times 10 to the 23rd, and I get 8.90 times 10 to the 23rd molecules of O2. The last example problems for this section are problem 10. Problem 10, we're looking for atoms of hydrogen from the mass of a compound. So in this case, 35.76 grams of calcium hydroxide. Calcium hydroxide is CaOH2. So the first thing I want to do is convert grams to moles. 1 mole, I need to find the molar mass of this, so I have calcium, 2 oxygens, 2 hydrogens. Calcium is 40.08 grams. Oxygen is 16.00 times 2, so a total of 32. Hydrogen is 1.01 times 2 for a total of 2.02. So 40 plus 32 plus 2.02 comes out to 74.10 grams. So that goes here. Then picking up here, after moles, I want to go to molecules. So there are 6.02 times 10 to the 23rd molecules of calcium hydroxide in 1 mole. But this question is asking me for atoms of hydrogen, so I need one more step. So for every molecule of calcium hydroxide, there are 2 atoms of hydrogen. So I'm going to multiply 35.76 times 1 divided by 74.10 times 6.02 times 10 to the 23rd divided by 1 times 2 divided by 1. This gives me an answer of 5.810 times 10 to the 23rd atoms of hydrogen. And let's do one more example. Let's do 10b. 20.02 grams of NaC2H3O2, sodium acetate. So I want to go 1 mole, and I need the mass of sodium acetate. So once again, I need to do Na, 2 C's, 3 H's, and 2 O's. Na 22.99, carbon 12.01 times 2, hydrogen 1.01 times 3, and oxygen 16 times 2. When you add all those up, you get 82.04. So this molar mass is 82.04 grams. Then I want to go to molecules. So for every 1 mole, I have 6.02 times 10 to the 23rd molecules. But I finally want to finish for every 1 molecule. There are 3 atoms hydrogen. So take the mass 20.02, divide by 82.04, multiply by 6.02 times 10 to the 23rd, multiply that by 3, keep 4 significant figures, 4.407 times 10 to the 23rd atoms hydrogen.